Hello, welcome back to the channel. Let's solve another problem from LeetCode. So that's called, today's problem is valid anagram, problem number 242. So we are given two strings s and t, and we need to return true if t is an anagram of s, otherwise we need to return false. So let's understand what's an anagram. Anagram is a word or phrase formed by rearranging letters of a different word or phrase, typically using all the original letters exactly once. Basically, in the example one, S is like if we say S is a rat, and and T is a tar, we are being asked if we can rearrange all the letters in S so that we can form T. So if we can rearrange this S, so basically we can easily make tar, right? This tar is equal to this one, right? So all the we can check all the characters in S. R, does it exist in T? Yes. A, does it exist in T? Yes. T, does it exist in as a character in T? Yes. In this case, we return true, right? And the second example, let's say if S is a rat and T is a car, are they anagram? Which means like, can we rearrange this S to form the string T? We can check R. Does R exist? Yes, it exists. Does A exist? Yes, it exists. Does T exist? No, it does not exist in T, right? Because there is a C. So basically, there is no way that we can rearrange all the characters in S to form this T just once, right? So basically, how can we solve this problem? So the first approach that we can think, we can, this one is a brute force approach, right? We can create, we can check the list of, we can check for each character, right? For each character in, let's say, an S, let's say for, we iterate for the first string. We just, for R, we look at R and we found this R, then we check if that exists in T. If it exists in T, let's say in the first case, S is rat and T is tar, right? We iterate through this all the characters in S, and we check for R. If let's say this R, then we remove that character from T. So we remove T. Then we go to the next element in S, which is A, and we also remove from T, from the second string, right? And we go to the second one, the last character. Then we see that this is T, it exists, we remove. Then we need to return at the very end, we need to check the length of T. If it's equal, then we return true, right? Otherwise, we will return false. For the second one, if for this approach, R, yes, it exists, and A, it exists, we remove them, right, one by one. And T, does it exist? No, it does not. So at the very end, the length of T will be 1. It will not be 0. That's why we return false, right? So this approach is basically for, we are iterating the first character, right? First string. And we are checking for each character in the second string. So time complexity for this will be O of n square, right? And space complexity will be O of n, right? So basically, initially, we are very first, we are going to check if the lengths of S and T, they are equal, right? If they are not equal, then we immediately return false, right? If they are equal, then we check for each character in S. If it exists in T, then we basically remove that character in T. Then for each character we check, and at the end we return true or false. So let's see how this code looks like, right? So this is a code. As I said, initially we check for the lengths, right? If they're equal, then if they're not equal, then we immediately return false. Then we convert this t in the to the list, and for each character in S, we check if that character of S exists in T. If it's in T, then we remove that character, right? If it's not in T, we return false. At the very end, we check the length of T. If it's 0, then it immediately returns true, right? So this is the first approach. And the time complexity, you can see O of n squared. If the length of each string, they're like huge, then this is not the most efficient approach, right? This is the first approach. And what is the second approach? Second approach is second approach is through sorting, right? Sorting. Let's say S is tar and T is again, let's say rat, right? If we just sort this, how it will be? The alphanumeric sorting, right? So that if we sort S, it will be ARST, right? Art. And if we sort T, it will be ART, right? We just simply sort them and we check if sorted S is equal to sorted T, right? So the A comes first and R comes second and T comes third, right? After we sort. We check if they are equal, then we return true, right? Return true. If, let's say, S is, let's say, rat and T is car, right? What happens in this case? We just sort this, then it will be ART. Then if we just sort this, ACR, right? They are not equal. In this case, we return false, right? So what's the time and space complexity for this approach? For this approach, time and space complexity will be for sorting, right? Sorting, it will take n log n, right? The sorting will be n log n for each one of them, and the space complexity will be O of n, right? This is the space, this is time complexity. So this is some improvement to our approach, but is that the most optimal approach? So in this is the code for in Python. We basically check initially if the lengths they are not equal, then we immediately return false. Then we just simply sort S and sort T, and we check if they're equal, then this will return true, otherwise it will return false, right? So this is some improvement, and but is this the most optimal approach to the problem? So there is the most optimal approach to this problem will be frequency counting, right? Frequency counting. So let's say S is rat and T is, let's say, tar. We basically count the frequency of each character in the strings, right? Let's say R one time, and the frequency A is appearing one time, T is appearing one time, right? And S. It's like a dictionary. And for T, it will be the same thing, right? T is appearing one time, A is appearing one time, and R appearing one time, right? So then we basically check if S, let's say this is S frequency, S T frequency, and S frequency. We basically check if S frequency is equal to T frequency, right? And So basically, this time complexity for this will be O of n, right? Because we are only iterating through this strings to count the frequency of each character. Then space complexity will be O of 1, right? Because this, it can be O of n, but in this case O of 1, because the strings contains only the lowercase English letters, right? We can see O of 1. So this is basically we can check here the code. So initially, what we do, we check here. We initially check if the length is not equal, then we immediately return false. Then we count the frequency s, and we count frequency initialize. Then we count the frequency of each character in s. For each character in t, we simply check their frequency at the end, right? This is the most optimal. But there is this is longer. But in Python, there is we can simply check the counter method. So s, we just simply check counter t, right? This is like one-liner, right? This will just simply do the job. So, and as I said, and this is the most optimal solution, and time complexity is O of n, space complexity is O of 1. Yeah, so if you have any question or comments on this, so we discussed 3 approaches. First is n square time complexity n square approach, and the second approach is sorting and checking if they match, and third approach is we simply count the frequency of each character in the strings. I think this is the most optimal approach. Yeah, if you have questions, then please write in the comments below. Thank you.